Alright, so this is lesson 2 of unit 3. Today we're going to talk actually about polynomial functions. Yesterday we looked at power functions, and so now we actually get to polynomials. So we start off here with polynomial function is the sum of power functions. It could also be differences, but it's going to be power functions added or subtracted together give us a polynomial. Alright? Notice we have f of x equals a sub n x to the n power plus a sub n minus 1 times x to the n minus 1, etc. Where the exponents are decreasing by 1 until we get down to a sub 1 times x to the first power plus our constant a sub 0 that does not have an x attached. N, the highest power, is the degree of the polynomial, and n is an integer greater than or equal to 0. Okay, so that's how we define a polynomial. All right, we have x to the n, x to the n minus 1. These numbers in front are called the coefficients of each term. A sub n would be the coefficient of x sub n. A sub n minus 1 is simply a number multiplied times x to n minus 1. So down below here, our first problems determine if each of the following is a polynomial function. If yes, give the degree and number of terms. If no, explain why not. So number 1, f of x equals 3x to the fourth, well, plus 6x squared minus 5. In fact, why don't you pause the video here, see if you can figure these out, and then come back and check your answers, okay? All right, so number 1, yeah, this is a polynomial. It is degree 4. This is a yes. Degree is going to be 4, and the number of terms, we have 3 terms, 3x to the fourth, 6x squared, and a negative 5. All right, number 2, this is no, because this is not x to some power here. All right, it is the square root of x. X does not have positive exponent. It has a square root on it. Number 3, this is a no because negative exponent. All our exponents on the x's will always be positive integers. Number 4, again no, x in the denominator. We will not have denominator, or we're not going to have x's in the denominator of fractions. Number 5, this is yes. We can have, because I could write this as, this is the same as 1/3 x minus 5. So yes, my degree equals 1. That's my highest power, is x to the first power. And I have 2 terms. Terms equal 2. Number 6, this is no. This is a rational. Again, I have x in the denominator. Last 2 here. Number 7, this is not written as we this is not in the same form as we normally see a polynomial, but we could multiply x minus 3 squared out and then multiply that times 5x, and yeah, we're going to get a polynomial. All right? Now what would be its degree? Well, when I square this x minus 3, I'm going to have an x squared term, and when I multiply that x squared times 5x, that leading term will be 5x to the third, and I'm going to have some other stuff there, but my degree is going to be 3, and how many terms am I going to have? I'm going to have, this will be a trinomial, and times that, it's going to be 3 terms here. So this is yes. D equals 3, T equals 3. Number 8, this is no. Exponent will be, should be, maybe I say it should be, positive integer, not x. Can't have x as an exponent. All right. So, determine the degree and roots of each polynomial. Use your graphing calculator to help sketch the graph, no y-scale. So we're not worried so much about how high and low it goes. We're just mainly worried about where it's crossing the x-axis here. So, if I put this equal to 0, to find where it crosses the x-axis, I can put this equal to 0. I can say 0 equals x minus 2 times x plus 3. And I'm going to get x minus 2 equals 0. X equals 2. So I'm going to cross at 2. And x plus 3 equals 0. X equals negative 3. 1, 2, 3. Negative 3 is going to cross the x-axis. All right. And so this thing, it's going to be doing this. It's going to be kind of coming down somewhere, and then it's going to be kind of going back up this way. Should look something like that. Okay, because it's going to be a quadratic. When I multiply this out, I'm going to have x squared and some other stuff. So it's going to be a quadratic. All right, next one. I can say again, if I put this equal to 0, I have x equals 0. And then I've got x minus 4 equals 0. And I have that actually twice. So I get x equals 4 and x equals 4. So I'm going to have it at x equals 0, I'm going to have an intercept. And then at x equals positive 4, I'm going to have a double intercept. And what that looks like is that my graph is going to go through at 0, and then it's going to bounce off. When it gets to 4, it's just going to touch the x-axis and bounce off. Now, the reason it does that, and the reason I know it does that, is because this is a double root. I've got x equals 4 twice, and when I have a double root, it does not cross through the x-axis, it bounces off the x-axis. All right, again, if I put this equal to 0, I'm going to have x minus 2 equals 0, x equals 2, and this is a triple root. This happens because it's to the third power. This is a triple root. So at x equals 2, I've got a triple root. Now it has this negative out front, so it kind of has, I have a x-axis reflection here. So it's going to be coming down, and when it gets close to the x-axis, it's going to kind of flatten out like the cubic function does. And then it's going to go through like that. Okay, it flattens out as it gets close. And the reason it does that, I know it does that, again, is because this triple root. It does pass through, it has 3 roots here, it's going to pass through, but it's going to flatten as it passes through. Alright, if I put this equals 0, I'm going to have x equals 0, that's a double root. And the reason why is because the square here, and then x minus 4 equals 0, x equals 4, there's a double root there. So I'm going to have a double root at 0, 1, 2, 3, 4. I'm going to have a double root at 4. Notice the negative out front tells me I'm going to have x-axis reflection. So this is going to be going, it's going to touch at 0, double root, it bounces off. And then it's going to turn back around and bounce off at 4 also and go back down. So it looks something like that. Okay? All right. Graphs of polynomials then. The graphs of polynomials are smooth and continuous. No breaks, gaps, holes, or sharp turns. Notice it's always just smooth turns. Domain's always negative infinity, positive infinity. The end behavior of the polynomial will be the same as the power function of the same degree. And we'll talk more about end behavior tomorrow. Polynomial degree n has at most n roots. So if it's degree 3, it'll have at most 3 roots. All right? For a single root, like I had up here on number 9, I had 2 single roots. Then when f changes signs at the root, f changes signs at the root, simply goes straight through, goes right through. Anytime I have a single root, it just goes right through, like we saw on number 9 and like we saw at 0 on number 10. It just goes right through. If I have a double root, f does not change signs. It bounces off. Okay, when I have a double root, it bounces off like on number 10 at 4, and then twice it happened on number 12. I had 2 different double roots there. Okay? And then a triple root, again, f changes signs, but we get this point of inflection. it kind of flattens out when it gets to the triple root. All right, like it did right here on number 11. It's going to flatten out as it passes through the x-axis. All right, so that will help us know kind of what we're looking for when we're graphing these things. So our last 4 problems here, sketch the graph of each polynomial using the roots of the function. So it's not quite as clear on some of these what the roots are. We're going to have to work it out. Number 13 though, it's pretty clear. If I put this equal to 0, I get x equals 0. X minus 1 equals 0 gives me x equals 1. X plus 4 equals 0 gives me x equals negative 4. So I've got a 0 at 1, at 0, and at negative 4. Okay, so this thing is going to go through at 4. It's going to come down. It's going to go through again at 0 and then turn right around and go back through at 1 and then keep going up there. So it should look something like that. Again, I don't know exactly how high it's going here, but the main thing is I know it's going up to the right, it's down to the left, and it just passes right through each of those 3 times. Number 14, I've got to factor this. So I'm going to factor an x out. That leaves me x squared minus 4x plus 4. And then that factors further to x minus 2 times x minus 2. So if I put this equal to 0, I get x equals 0. And then x equals 2. Well, let's just say x minus 2 equals 0, x equals 2. And that's going to be a double root. So at 0, and then at 2, I've got a double root. So this is going to, so this has degree 3. It's going to be coming right through at 0. And it's going to turn around, and then it's going to bounce off at 2. And so it should look something like that. All right. Number 15, negative x to the 4th minus 3x to the 3rd. I'm going to factor out a negative x cubed here. Sorry about that. Negative x cubed. And that's going to leave me x plus 3. Alright, if I put this equal to 0, negative x cubed equals 0, x equals 0, that's a triple root. X plus 3 equals 0, x equals negative 3. Alright, so at 0, I've got a triple root, and at negative 3, I've got a single root. Has a negative sign up front, so that means I've got a x-axis reflection. So it's going to go right through at negative 3. And then it's going to do its little inflection point when I get close to 0 here. It's going to kind of flatten out here. And it should look something along the lines of that. Last one. I know I'm going through these pretty quick, but hopefully you're catching on this. Factor out, I've got a common factor of x squared. I'm going to factor that out. X squared minus x minus 20. And then that factors further to x minus 5 and x plus 4. Negative 5 times 4 is negative 20. Negative 5 plus 4 gives me that middle coefficient of negative 1. So if I put this equal to 0, I've got x squared equals 0, x equals 0. That's a double root. So it's going to bounce there. X minus 5 equals 0, x equals 5. X plus 4 equals 0, x equals negative 4. So 1, 2, 3, 4, 5, positive 5. 1, 2, 3, negative 4. So this is going to be coming down through negative 4 and goes straight through at negative 4. It's going to bounce off at 0, so it just touches at 0 and then turns back around, and then positive 5, it goes right through and just keeps going up. So it should look something like that. Alright, I know that was fast and furious. Hopefully you caught on with all that. Let me know if you have any questions, and I will talk to you later.